Bimanual coordination is a motor skill that requires simultaneous use of the two hands. And interestingly, the bimanual coordination, the Fitts law doesn't really apply in bimanual coordination. So it was identified in Kelso, Southard, and Goodman's study. I'll explain this study shortly. So the task, this was the start circle, and the target was at this point. So the aim was to move as fast as he could to the target, and the movement time was recorded. So this was for the right hand, and the shortest movement time, can you see, it's about 220 milliseconds. So they also did for the left hand alone. So left hand starting point towards the target as fast as it could, and the time, this one, was about the same, 220 milliseconds. Well, I just circled those two, so I'll just explain this first. When the target is closer to the starting point, so the amplitude is less, the movement time will be less. So in fact the movement time was 140 milliseconds for this case, right hand. So it's showing the different trials, what they use in different trials. So trial 1, they use right hand with this amount of amplitude, so on. So let's look at the trial 7, which is the bimanual coordination. So they started at these points, different distance and different target widths, and try as fast as he could to reach the target. So like that. Yep. So what do you expect? Which one is difficult? This one is more difficult because it has smaller target widths and larger amplitude, and this one is easier. So what was the movement time for this alone? It was 140. So we would expect if it was just right hand only, it will be 140 milliseconds. But if we do the bimanual coordination, so doing the two hands simultaneously, what was the result? What was the movement time? Movement time was almost 190 milliseconds. So it increased. The movement time increased. And what was the movement time for the difficult one? It was about 210 milliseconds. So both tasks, the movement time became similar. In other words, the difficult task, more difficult task, affected the easier task. Because remember, the same difficulty for one hand, this one was about 220 milliseconds, and it's about the same, 210 milliseconds. So this one was not that affected, but the easier one was affected. The movement time became longer. So Fitts law doesn't apply because more difficult tasks influence performance of doing less difficult task. So Fitts law doesn't apply in bimanual coordination. If you look at other research is done on bimanual coordination, we can refer back to the perception study, which have looked at the task intrinsic feedback lecture. So it was about vibration, tendon vibration. On bimanual coordination. So what was the task? The task was to draw a circle without looking. Yeah. So this was normal situation, and this was vibration on the deltoid on the dominant hand. And And what was the results? While doing the circle drawing without vision, the tendon vibration made the circle to drift towards the left. And other finding was that the hand that was vibrated, they had the face lead compared to the other hand. Face lead, well, if we start at this point and draw a circle, and if we start at this point and draw a circle, those two circles are in phase. If I start earlier and draw a circle, well, it's a bit difficult, like that, and this circle is in phase lead. So it starts a bit fast than this circle in a cyclic motion. So not only the shape of the circle drifted towards the left, but also it shows the phase lead. Before it was in phase, so the phase angle was almost 0 for those circle drawing, but after vibration the phase lead occurred in the dominant hand. Other studies have found the role of perception, so visual perception. And normally 4 to 3 frequency ratio of drawing a circle or doing a cranking motion is impossible without any aid. But they demonstrated that with the visual aid, this ratio could be kept. So the hand motion showed this ratio, 2 hand motion, while looking at these visual cues. Well, they did it in a smart way because they had this gear which created the 4/3 changes in the cranking motion. So if the hand cranked off this cycle, the top of the visual circle is representing the ratio of 1. And this, in other words, let's have a look at this pattern. When they see the dot turning in phase by cranking the shaft, even though the circles are moving in phase, it will create 4 to 3 ratio of the hand motion because of this gear. So in other words, by this visual cue, they were able to do 4 to 3 frequency ratio. They did another study which shows this hand coordination, finger coordination. It's found to be easier to do in phase, this motion, than the anti-phase. In phase, so why is it easier? They thought, the researcher thought they used the same muscle. So if I move like this, the same muscle here is used, so it's in phase. But when they do like this, so it's this muscle, when this muscle contracts, the same muscle will create this. So in theory, this would be easier than this for this situation, but it wasn't. It was actually, this was easier than this one. So this was easier. So the perception from the vision is somehow tightly linked with coordination pattern. So that was what they found in their research.